Hello and welcome. I just want to introduce you to Ciaran Conliffe. He's a security architect in Rapid7. He's spent over 20 years in application development, and with the last 10 years in areas of secure development and security engineering, before moving into information security. We're going to hear from Ciaran about tractors and hackers, and I'll pass over to Ciaran now. Thank you.
Thank you. So as I said, my name's Ciaran Conliffe. I'm the lead security architect at Rapid7, and I'm here today to talk to you about tractors. So I always like to give a little bit of historical context at the start of my talks, and this time around we have to go back nearly a century to 1925. That's when a group of light bulb manufacturers got together to form the Phoebus cartel. And this was an international group that was formed for all the usual cartel purposes of manipulating the market, fixing the prices, freezing out competitors. But one of the things they also did was agree on a maximum lifetime that light bulbs could last. And if you were a member of the cartel and your light bulbs lasted for longer than 1,000 hours, you would be fined. Now, in some senses, this is just another example of planned obsolescence, like you see in the clothing industry, where they use fashion trends to make people buy new clothes before they strictly need to. But on the other hand, what they were doing was they were compromising the engineering quality of their product in the name of increasing profits. They made a lot of noise about how this is about energy efficiency, but really it was just to keep people buying light bulbs. So it's a slippery slope, that, and it's the start of that sort of concept. So jumping forward to 1966, that's when IBM released the System 360 mainframe. This was a revolutionary device for a whole bunch of reasons. The main one is that it was the first time someone separated the implementation from the architecture, which in practice meant that you could buy multiple different versions of the same mainframe with different specs, as opposed to previously, like if you bought an ENIAC, you bought an ENIAC, and that was that. But from our point of view, what's interesting is that this is also where software and hardware became very distinct. And this posed a bit of a problem for IBM, because at the time, software wasn't copyrightable. So they were worried that their competitors might just take their software and reuse it in their products. So in order to get around that, they invented the idea of licensing software. And rather than selling you the software, they sold you a license to use the software. That had conditions attached to it, and that meant that you couldn't copy the software and do whatever you wanted with it. By the 1980s, software was copyrightable. Classic 1980s word processor here. But the whole practice of licensing software still continued, because it turned out it fit very well into the corporate ecosystem. Companies love to buy equipment and vehicles, for example, on annual leases rather than buy them up front, because it means that your expenses are spread out year on year, which is much nicer for accounting, and it means that you can cut those expenses if you have to. And so licensing software on a year-by-year basis fit in very nicely to that. And it was very nice for the software companies because it gave them an ongoing revenue stream. And this is why you still see things like Microsoft Office moving to a subscriber model, because they'd like to shift the individual consumers into the same model as well. So talking a lot about software, what has this got to do with tractors? Well, tractors are computers, obviously. And this is the official position of John Deere Incorporated. John Deere is one of the largest agricultural machinery manufacturers in the world. They have 60,000 employees. They were founded 183 years ago, and they were actually founded by John Deere the man on the basis of him inventing the first self-scouring steel plow, which is a plow that was specifically designed to work with the soil in Midwestern USA as opposed to European soil. So it was a big improvement. So they're a company that was founded on innovation, and they take that idea very seriously. In 2017, for example, they bought a Silicon Valley machine learning startup, and some parts of them see themselves as more a tech company that sells tractors than a tractor company that dabbles in tech. This is also a view that they have actually gone to Congress to defend. In 2014, there were proposed amendments to the Digital Millennium Copyright Act that would allow people to bypass software protection mechanisms in vehicles in order to repair those vehicles. And John Deere went against filed an opinion saying you shouldn't allow people to do this. And they explicitly said this is because these are computers operating software, and it should be treated exactly the same as any other computer operating software. So that's like fancy legal stuff, but what that meant in terms of real-world impact came very much into public view the following year in 2015, when Wired published an article called "New High-Tech Farm Equipment is a Nightmare for Farmers." And this talked about the issues that farmers were seeing repairing and maintaining this high-tech equipment. The central story was of a farmer named Dave who had a hydraulic sensor fail in his tractor, and this is like a very small, simple component that shouldn't even be critical, but with it failing, the tractor wouldn't start. And the local repairman replaced the hydraulic sensor, and it still wouldn't start, because it turned out the only way to get it to work was to get an official John Deere repairman to come out, replace it with an official John Deere sensor, then plug in his computer and tell it it was okay. And this effectively meant that John Deere were operating a repair monopoly on their own equipment, which was very profitable for them, and obviously quite expensive for the farmers. But a bigger impact on the farmers was that this meant machinery would be sitting idle, because it would take an average of 2 days for the John Deere repairman to turn up. And if you're in the middle of harvest season and you've got a combine harvester worth $250,000 sitting there idle, like that's a really serious financial impact to a farm. So, but the other interesting thing about this, though, is that this whole not being able to just replace the component actually goes against one of the biggest engineering innovations in modern vehicles. And to explain that, I need to get a little bit into the controller area network, which is the way that all the different pieces of your car are wired up together and talk to each other. I won't get too deep into it. I did an entire talk about this in a previous NIDC. As I said, I think it's one of the greatest engineering innovations of the 21st century, so I can nerd out about it to you later. But basically, one of the innovations of it is the way the components talk to each other. By one node will just put data on the network, and then other nodes will be able to look at who that's addressed to and go, yes, this is for me, or ignore it. And what this means in practice is you're set up for plug and play. If you want to replace a component, you don't have to completely redo your network. You just plug in a new component that has the same ID, and it gets treated exactly the same. So that's what should be happening. Clearly, that's not what was happening in these John Deere tractors. So why is that? Well, let's take a look at the architecture of a modern vehicle. This is not the architecture of a tractor. Most vehicle manufacturers don't make their architecture diagrams public. There is actually a law that has been passed in Massachusetts to compel vehicle manufacturers to make this sort of diagram public, but it's being held up in the court by the automotive lobby. So if that passes, there will be lots of fun architecture diagrams out there for us to nerd over. At the moment, we have to make do with this, which is one that was created by the University of Munich as an example architecture. You can see the way this works is you have all these different components that control different parts of the vehicle, whether it's acceleration or windscreen wipers. But you also have this central control unit in the center that sort of directs traffic. And in the case of the John Deere tractors, this was keeping track of, here are all the registered components of the tractor, and if a component was replaced, it would just say, I won't start unless someone plugged in and reprogrammed it to say, yeah, no, this is okay, now you can start again. So obviously this posed a problem for the farmers, but anyone who spent any time on a farm knows that a large part of farming is solving problems. Farmers are the original engineers. The oldest tools known to humanity are farming tools. So like engineering as a discipline grew out of the agriculture. So a lot of effort went into reverse engineering these systems of John Deere and figuring out how to get around them. Obviously this was of dodgy legality, so there's not a lot of real-world examples I can share with you of this. Fortunately, we have an alternative to the real world, which is academia. So let's look at some academic research into this. One example of that was California Polytechnic's tractor hacking project. Now, I've picked this for a couple of reasons. The main one is that this is up on GitHub, so you can go and look at their code and their documentation and everything if you want, and it's quite interesting stuff. But they basically set out to figure out what was going on and document it. The first thing they did was get an actual central control unit from a John Deere tractor and crack it open and see what was going on inside. They found there was a complex programmable logic device, which was essentially, among other things, acting as the memory of the unit. So that's where this list of components was stored. And there was also a 16-bit microcontroller unit, which was the brains of the whole operation. Now, this is basically the same sort of setup you would see in the control unit for a regular car. And that's because the actual tractor they were doing was a simple open cab John Deere tractor. So effectively the equivalent of a regular car. In fact, it was this open cab tractor that you can see on the left here with a student having a lot of fun pretending to drive it for the photo. So since this was an academic project, they started at first principles, and so they got their actual tractor, they plugged an oscilloscope into it, and they started measuring the traffic on the network. I mentioned earlier, the whole thing with the CAN is all the traffic is on the network and nodes either pick it up or ignore it. The CAN bus port is just another node on the network. So you can just plug into that and listen to all the network traffic if you want. Their oscilloscope thing didn't go so well. 1.4 seconds of traffic turned into 25 gigs of data, at which point their hard drive ran out of space. They got a slightly better oscilloscope and got slightly better data efficiency. All they were able really to do, though, was detect that, yes, it is using CAN signals on the CAN network. So with that out of their system, they did what any normal person would have done right from the start, which is they took a cannibal board and plugged into it instead. This is effectively a USB to CAN adapter. It's an open source board. Again, you can go to cannibal.io and look up the design for it. And this allowed them to read all the traffic on the network. They had a database. They built a program called Polycan to track it all. They had a database that they preceded with all the standard CAN commands, and then they were able to go, and this one we don't recognize, and this one we don't recognize. So this must be John Deere specific things, and figure it out from context. Their second step was going to be building an emulator for the central control unit, but they ran out of time because this was an academic project. They were only doing it for a year, so they just wrote up what they had and submitted it as their thesis, and they were done. So again, academia, like, this is all interesting, and this tells us a bunch about what's going on, but it's not necessarily as useful in the real world, and it wasn't as practical for the farmers as they'd hoped. So instead, the farmers turned to a different, much simpler solution, which is buying pirated copies of John Deere official software on the dark web. The main pieces of software that they got, and they bought these, like this is on this sort of dodgy forum where you have to get instructions to get onto it, and it's like all Tor connection, but you go onto a regular internet website and buy a non-existent part, and instead of sending you this part, you get emailed instructions on how to connect to it. So it's all kinds of cloak and dagger fun. But the main pieces of software they were looking for there was John Deere Service Advisor, which is the piece of software that those official John Deere repairmen would have running on their laptop, and it would let them reprogram the central control unit and key generators for it, obviously, to let them use it. And then also payload interceptors that let them do things that the regular software wouldn't necessarily allow you to do. For example, like the regular software might say, oh, the maximum speed limit you can set is 40 kilometers an hour, but if you can modify the payload, you can set it to 50. So all kinds of fun things. Usually it wasn't the actual farmers getting this stuff. By the way, it was independent repairmen servicing them, but same diff. So all of this, like the whole idea of farmers having to break the law in order to keep their equipment running was wonderful. Like the media loved this story. They ate it up. Big company versus little farmer. It was just like fantastic stuff. And it was like effectively a matter of life and death for a lot of these farming businesses, because farming bankruptcies have been on the rise in the US since 2014. And a lot of the cases, like they've got this really expensive farming equipment, but it's actually all mortgaged, so they don't, like, they're having to keep up payments on it, and it's very easy for them to fall behind. So this was a really good narrative, and it played well in the media, and it got a lot of press. In the meantime, John Deere actually lost the argument to avoid having the DMC amended, so they didn't have any legal protection against people doing these things now, but so they did what IBM did in 1966 and just bound it all up in license agreements instead, which again didn't go down too well in the media just because, the law didn't go their way, so they're making up their own law. By 2017, Vice described farmers as the leaders of the right to repair movement. And this was a movement that had been around since the 2000s. It started with things like Apple laptops and so on, but it kicked up then when smartphones came in, and just the idea that if you own this electronic device, you should have the right to get it repaired. You shouldn't be forced by the manufacturer to buy a new one if there's a minor fault with it. All of this, like, it didn't really resonate with people the way the idea of a farmer struggling to keep their business afloat did. So John Deere became the villain that the right to repair movement needed, and this turbocharged it, and it really started moving it forward. Another impact, though, that all of this media narrative and all of these things had was people started buying vintage John Deere equipment rather than brand new stuff, because they were just like, well, all this new stuff, it's such a hassle to repair. I'd much rather buy one of the old ones that was easier. So older farm equipment sales started to rise, new equipment sales started to drop, and it really went against the media narrative of John Deere wanted, or the corporate image of the innovative company when their innovations are being rejected. So in 2018, John Deere tried to seize control of the media narrative, and they did this by giving in, but with a lot of caveats. And what that meant was effectively a law was passed in California that had been written by their industry lobby, and it said, yes, you do have the right to repair your equipment, but you're not allowed to reset immobilizers, you're not allowed to reprogram electronic control units, both of which you would need to do in order, for example, for Dave to replace that hydraulic sensor we talked about earlier. There's no changing equipment or engine settings that might negatively affect emissions or safety, and that might does a lot of heavy lifting in the story. So yeah, it basically still prevented all the repairs that people actually wanted to do. The worst part about this whole toothless deal, though, is John Deere didn't even honor it. Part of the deal was they would start selling diagnostic software in 2021, and they would start selling spare parts to independent repairmen, and they didn't follow through on it. So this led to a whole bunch of class action lawsuits being filed against them. 2021 is also when actual hacker enters our story, an Australian ethical hacker named Sick Codes. Well, not named Sick Codes, but you know what I mean. So in April of 2021, he disclosed a couple of bugs on John Deere's website to the company and got a fairly rough disclosure process, which for security researchers is usually a red flag of, oh, I should look at this company a lot more. They've probably got a really bad security culture. So he and a bunch of other researchers got together and did what they termed an unofficial audit of John Deere and a few other agricultural manufacturers, and put a talk out at DEF CON with, hey, here's all the results of all the exploits that we found. And again, John Deere didn't respond to this too well. They basically said, oh yeah, the vulnerabilities are there, but none of them actually would impact on a real world system. So the following year at DEF CON, Sick Codes did the next best thing he could to driving a tractor onto stage, which was that he took the video display unit from a John Deere tractor and the central control unit and basically all the electronic guts, so it was a real system. And he used those exploits to jailbreak it on stage. And then once he'd done that, he did what is the inevitable fate of all electronic systems ever, which is he installed Doom on it. Specifically installed a custom version of Doom, which had you driving a tractor around running over aliens in a field, which is quite funny. Almost as funny as the fact that while he was doing this, he noticed the software that was originally running on it was using software libraries that had GPL3 licenses. And GPL3 is the not for commercial use license. So the whole publicity stunt of running Doom in a tractor got a lot of press, but so did this idea of John Deere as hypocrites because they're enforcing this strict licensing terms, but they won't follow other people's licenses. So again, not great media. By this point, John Deere's whole strategy was completely wrecked. 20 different states had right to repair bills on the books working through the systems. And in 2022, New York became the first to pass a right to repair bill. It only covered consumer electronics, but it was a crack in the wall. And this year, Colorado became the first state to pass a bill that covered agricultural machinery specifically and laid out all the rights that the farmers wanted. By this point, John Deere had given up. They signed a memorandum of understanding with the, blank the name of like the farmers' body in the US, and they started giving out all the different things that they'd been asked for. So they started giving up the details that allowed third-party tools like DimSport and KES to access the ECU and tune it. They started selling the spare parts to independent manufacturers, and they even started selling the John Deere Service Advisor software. But of course, because it's software, you can only buy it in an annual license. So that's where this story is at the moment. Like, history never ends and so on, so this is still evolving. At the moment, it looks like this is a victory for the right to repair movement, and John Deere have been defeated, but doubtless there will be more things to come on this in the future. Before I sum up, I want to talk a little bit about one group that's been behind the scenes on this a bit. As I mentioned, the whole right to repair movement is broader than just the tractors, and iFixit.com is a company that have been at the center of it in the US for going on 20 years. It was originally set up, as I said, as a place to host details on how to repair Apple Macs. The CEO of iFixit.com wrote the original Wired article back in 2015, and as you might have noticed, they sponsored that California Polytechnic project. So it's also like if you like having random video tutorials running in the background to distract you, if you're a weirdo who finds that soothing, then it's a great resource. And if you actually want to fix something, I suppose it's useful too. So summing up, what have we learned? Or what have I learned anyway? Number one is don't be a snob. When I told people I was giving this talk, a lot of people went, sure, what has farming got to do with tech? Why are you chatting about tractors at a developer conference? Simple fact of the matter is that in 2023, tech has permeated every aspect of life, and people have had to learn about this stuff because it's a part of their job. We can't really treat ourselves as siloed out from the rest of the community. Another thing I want to note is this isn't just about John Deere. I've focused in on John Deere because they were the bad guys of the narrative. They were the main characters of the day. But loads of companies are trying to do similar things and shift to similar models. One of my favorite examples was last year when BMW said they were going to start charging a subscription for heated seats. Which in practice meant you would buy a BMW, it would have heated seats fitted, but you couldn't turn them on unless you paid them 15 quid a month. So again, didn't go down well. Owning things is a human right. The right to repair is just an aspect of the right to property, and the right to property is not as absolute as people tend to think these days. People take it for granted that, yes, you can own things, but say 700 years ago under the feudal system, nobody owned anything. Like, or rather, if you were a peasant, everything you owned or everything you had was in trust from your lord, which was in trust from their lord, and all the way back up to the monarch, the king or the queen, who was the only person who actually legally owned things, which meant that, especially land, but in practice, pretty much anything, but this meant that because your ownership was a privilege, it could be revoked at any time, and they could just say, no, we're seizing it back. And this is, like, if that seems outlandish, think about if you play video games on PC, think about what would happen if Steam decided they didn't want to have you as a member anymore. For example, like, all the video games you think you own are just gone. And last thing is, this is just part of a broader conversation that I think needs to happen in the tech industry about ethics in general, because this is an example of profit-driven engineering and people really just thinking in short terms of how do I deliver value, how do I move the needle on a key performance metric, as opposed to is this the right thing to do? And I think that's a conversation, that's a much bigger conversation than a silly little talk about tractors, but I think it's one we need to start having as an industry. Finally, and almost completely irrelevantly, if you like this talk and if you like true crime, then please pre-order Women Who Murder, which is an anthology of true crime stories that includes an essay by me about a murder that was happening right around the time the Phoebus cartel were figuring out how much they were going to charge people for light bulbs. So if that's your sort of thing, then check it out. And with that shameless self-promotion aside, we might have time for a question or two. I'm not sure.
I think we probably have a question, or time for a single question, and I see one just coming there.
Yeah, I cannot guarantee I'll be able to answer it, but...
I don't know. Just back in your summing up there, you talked about this subscription model that people are bringing in, of manufacturers, and one is the manufacturer of orange motorcycles with their demo mode was quite a famous one in my field of interest. And then you talked about ethics in the last one. So do you know, has anybody come to an ethical position, or has there been any legal testing of people bypassing these restrictions in the vehicles that they have purchased in order to unlock features that are locked but are there in the vehicle they purchased?
Yeah, I don't think there's been the legal testing around it. I think like it happens. and people are doing it, and it's not something that I've seen much coverage of it being chased up on. Like even things like the independent repair shops using the pirated software, like that's very clearly illegal because it's pirated software, but it was effectively not really enforced just because, again, the optics of going after it. I think it depends on how integrated it is to a company's business model. Like, if it was BMW and it's just this one thing, they might not want to chase it up, whereas Tesla's business model is built very much around that sort of approach, and I think they'd probably take a much more hardline view on it if people started messing with those features, but I don't think it's like tested water at the moment.
Thank you very much, Ciaran, and I appreciate we haven't opened the floor for wider questions, but understand you can be contacted on socials, and thank you for putting up those details. We are now entering a break, and you can move to the exhibition hall, which is on this floor, for some refreshments now. And again, thanks to Ciaran.